Okay, here we are on section 4. Section 4 is titled Distributive Property. The distributive property. The distributive property is a property that we will use extensively in all math from here on out. How will you know if it's the distributive property? Well, a distributive property is when you have something being multiplied to a quantity, like this right here. So you will have a number or a variable or a combination of numbers and variables butted right up against a parenthesis. And on the inside of the parenthesis, there will be more than one thing, more than one term, distributive property. And here are my notes for the distributive property. Let me find them. Pause the video and take a few minutes to write these down if you need to. I'm going to have more notes in just a moment. After you write those down, keep them with you so that you will have them to use when you do your work. Now this section actually introduces not only the distributive property, but combining like terms. And it gives us these two examples. In order to combine like terms, a term is a number or letter, or numbers and letters together that are separated by a plus or minus sign. Here's one term, here's another term, here's another term. For this other example, there are also three terms, this one, this one, this one. In order to put them together by adding and subtracting, then they need to have like things. Like things are like 5, 4, 1. They are all three just numbers with no letters with them. These are all like terms. So these can all be combined. 5 plus 4 is 9. Take away 1 is 8. These also are all like terms. There's an a to the first power. Here's another a to the first power. Another a to the first power. Another a to the first power. The number in front tells you how many that you have to add or subtract. There's no number written in front of this a, but there's only one a there. So I don't need to write a 1 in front of it. This is 1a. Here's 3 more a's, and I'm adding them together. So when I combine these two, now I have 4 a's. I'm going to combine another 7. So now I have 11 a's. And now I need to take away 2 a's. That leaves me 9 a's. 1 plus 3 is 4, plus 7 is 11. Take away 2 is 9. Here's an example of where you might have some terms that are like and some that are not. A to the second power can combine with another a to the second power. There's 6 of them here. There's 1 of them here. 6 plus 1 is 7. This term also has an a with it, but it's not raised to the second power, so we cannot combine it with the other two. The only thing that we can do is bring it down and write it in our answer, plus 2a. So 7a squared came from 6a squared plus 1a squared. 7a squared plus 2a. In order to combine them, the letters have to be the same, the powers have to be the same. All right, the distributive property. I'm going to show you what I call the simple distributive property, because we can make this as difficult as you can imagine, or we can follow a process and it can turn out to be pretty straightforward. Simple distributive property. Whatever is on the outside of the parenthesis is going to get multiplied to everything on the inside of the parenthesis. If you have two things on the inside of the parenthesis, you're going to have two multiplications. If you have 8 things on the inside of the parentheses, you're going to have 8 multiplications. So let's look at some examples. Here I have 5 times the quantity 3 plus r. I like to draw these loops just so I don't miss anything. I drew this one first. 5 times 3 is 15. I did that multiplication. I wrote down the result. Now I take this operator, the plus sign, and I stick it right there since the things that I'm multiplying are all positive. Now it's time for the second multiplication. 5 times r. 5 times r is 5r. And that one is done. 15 plus 5r. They are not like terms, so I cannot combine those. It is finished. All right, let's look at another example. Now watch as I do this. I've got one number being multiplied to 3 terms. 1 times 3 is 3. That means I should write out in my final expression 3 different terms. 1 times 3. Right, here's the first one. Negative 2 times 3x. What I'm going to do in this process is I'm going to multiply this number to the number in front of x. X is not going to be changed in any way at all. I'm simply changing the amount of x's that I have. It's negative 2 times positive 3 is negative 6. That is how many x's I now have. It's first multiplication. Second one, using that negative 2 again, negative 2 times 7y. I'm not going to change the y in any way. I'm simply changing the amount of y's that I have. So it's negative 2 times positive 7 is negative 14y. Now finally, negative 2 times negative 4. Negative 2 times negative 4. And when you do multiply and divide, this minus sign becomes a negative sign. So negative 2 times negative 4. Negative times negative makes a positive. And 2 times 4 is 8. And there we go. That's the final answer. So here's how the book does it. And I don't care if you use the loops or if you do the way the book says. The book says you write each one of these as an independent product, meaning negative 2 times 3x plus negative 2 times 7y minus negative 2 times 4 equals. You end up with the same answer. Negative 2 times positive 3 is negative 6x plus negative 2 times 7 gives you negative 14. A negative, positive with a negative makes a negative, so minus 14y. Minus negative 2 times 4. A negative and a negative give you a positive, so plus 8. Same answer. I prefer doing it with the loops. It's easy to miss something doing it this way, but it's your choice whichever way that you want to do it. Now sometimes they'll give us the distributive property and it will look backwards. Multiplication is commutative. We can change the order. instead of doing 8 plus y times the quantity 3, you can change this to 3 times the quantity 8 plus y. Did you see how I flipped it around there? The order that you work will still be the same. It'll be 3 times 8, or here it would be 3 times 8, which is 24, plus sign, since everything is positive, 3 times y, or 3y. Y times 3, or 3y, and that's done. All right, so let's look at some of the work. How are you going to do the work? Be sure you read all the way through 25, 26, 27, and 28. All right, the work. I'm going to do some of the odd numbers, and then you will have the even numbers for your assignment. Number 1. A pilot at an air show charges $55 per passenger for rides. If 12 adults and 15 children ride in one day, write and evaluate an expression to describe this situation. Obviously, they're wanting us to use the distributive property. Everybody is going to pay $55, whether they are adults or children. So here we go. It's $55 each. There's 12 adults, 15 children. If it were just adults, it would be 55 times 12. If it were just children, it would be 55 times 15. But it's both. So these two quantities get added together. You don't need letters with them, just the number of adults and children. So here's our expression using the distributive property. $55 is going to be charged to 12 adults, 15 children. It's the same amount for both, so we can go ahead and combine these two together. And it's 55. We can go ahead and combine these. 55 times 27, or $1,485. We could also have done 55 times 12 plus 55 times 15. 55 times 12, 55 times 15. But following our order of operations, that would be redundant. We don't need to do that. Combine the like terms, and there's your solution. Okay, number 3. The instructions are: use the distributive property to rewrite each expression, then evaluate. Read example 2 on this. It tells you what they mean by rewriting each expression. For number 3, it's 6 1/9 times 9. Well, remembering your mixed numbers, 6 1/9 actually means 6 plus 1/9. This is what we're going to use for our distributive property. We're going to have the quantity 6 plus 1/9 being multiplied to the number 9. We can flip that around if we want to. We can do it the same way with loops. 9 times 6 and 9 times 1/9. 6 times 9 is 54. 1/9 times 9 is 1. And the answer is 55. Okay, number 5. Instruction for number 5. Use the distributive property to rewrite each expression, then simplify. When it says simplify, that normally means we're not going to get just a number for an answer. So here we go. The distributive property what it's actually telling us is, I'm going to take this quantity and you're going to be adding it this number of times. If you're a very literal person, if you've just got to see what is being done here, I did it as an example over here. That means take all of this and add 6 of these together. You've got this 6 times. So what would you have to do? Well, you would have to put 6 of these in a column and add all of the rows. Add all of the columns together, the like terms. G squared is not like G, different powers. 3 is not like any of the other 2 terms. So the only thing you could do is add together the G squares, the G's, and the constants. Look at what it turns out to look like. This is 2G squared plus 9G minus 3 times 6. I wrote that expression down 1, 2, 3, 4, 5, 6 times. When you go ahead and combine like terms, you have 2, 4, 6, 8, 10, 12 G squares, 9, 18, 27, 36, 45, 54 G's, 3, 6, 9, 12, 15, 18, so minus 18 for the constant. This takes a lot of paper. It makes you use your brain. We can't do that. That's why we like the distributive property. It makes it a much shorter process. So if I distribute this 6, and this is the way the book wants you to do it, so that's the way that I wrote it out. I would much rather just use loops, but here we go. We distribute this 6 to each term in here. 6 times this, 6 times this, 6 times this. And this is the way that it looks. The next step is completing each multiplication. 2 times 6 is 12. 9 times 6 is 54. 3 times 6 is 18. And here's your answer. Number 7. Simplify each expression. If not possible, write simplify. It's much an exercise on combining like terms. I have x's to the 3rd power, y's to the 3rd power. Yes, they have the same power, but they're not the same letter. They cannot be put together. Then I have the constant 14. It doesn't have any variables with it, so it can't be combined with either of those. It's done. It is simplified. Number 9, they give us a word problem. 4 times the sum of 2 times x and 6. So let's analyze this word problem. We need to write it out. It says 4 times. Okay, so 4 times. The sum. The 4 is going to get multiplied to a sum. That's at least 2 things being added together. I need 2 things to come after this that are going to be added together. That tells me I'm using distributive property because I'm going to multiply 4 times at least 2 different things. Sum. So the next 2 things are the 2 things that are going to be added together. 2 times x, that's 1 thing, and 6. Now, how do I know it's the sum of 2x and 6 rather than the sum of 2 and x? Because of this word and here. The sum of, well, what do you want me to add together? 2x and 6. So here we go. 4 times the quantity, or the sum, 2x and 6. I'll clean it up just a little bit. 4 times the quantity 2x plus 6. Here's the way the book does it. Distribute this 4 to each term. Here's how I would do it. 4 times 2x plus 6 is 4 times 2 is 8 with an x. And 4 times 6 is 24 without an x and a plus sign right in the middle of them. 4 times 2 is 8. 4 times 6, 24. So this is the way that your work should look. You won't have this. This was just an example of showing you what that actually meant. Other than that, this is the way that your work should look. Nice and neat. Each step done. And your assignment is going to be the evens 2 through 24. You can leave out number 12. Okay. 2 through 24 evens except number 12. There you go.